This is Rui PCB, your trusted PCB partner. Today we'll be discussing important considerations for hierarchical design in KICD. Generally speaking, KICD recommends using hierarchical design as it provides a clearer structure and makes reuse more convenient. For simple systems, a flat design is also easy to implement, but designing complex systems in a flat manner is not so straightforward. Previously, we spent 2 episodes introducing hierarchical and flat design, so now we need to pay attention to label types and their priorities. KICD has 3 types of labels, and the generated net names are determined by their priority. First, the highest priority is the global net, like this one here, which is a global net. You can set it here, and as we've already discussed, power and GND are by default global net. Next, let's take a look at the label for the global net. It's the value we see, for example, this plus 5V. If we check its label through the associated net class, we can see that its label is plus 5V. Then there are hierarchical labels, which have the second highest priority. The nets they generate will display the label name and are distinguished by starting with a slash. For hierarchical labels, we need to look inside the hierarchy. This is a schematic we worked on earlier. I added a page to turn it into a hierarchical label. I made these A, B, C, and D into the interface of this sub-schematic, so they are hierarchical labels. Let's take a look at what its label name looks like. We can see that there's a slash added before the A. This indicates a hierarchical label which has the second highest priority. Next are local labels, also known as local tags, which have the lowest priority. The nets they generate not only display the label name, but also use the label name from the current schematic sheet. Let's carefully observe what that actually looks like. If you use the very same label name on the same schematic sheet, those particular labels will be connected together automatically, even if their specific types are quite different. For example, if you use a local label and name it A, and there's another A present on the very same page, they will be connected together, forming a single logical connection. Even if one is a local label and the other is a global label, we can take a look at what the name of the local label looks like. We didn't look at it in detail before, but now we can see its name. Although what we see here is QC, in the system, KICD assigns it an absolute label value of LED2QC. This is because our file name is LED2, so it adds a slash and the file name in front of the label. This is used to distinguish it from, for example, the QA we have on the previous page. Let's take a look at the label for that QA. It only has a slash without the file name, without the root file name, because it's at the top level design. By default, it assigns it according to the hierarchical label standard. This way, even if the 2 pages look the same, they won't be connected together. Global labels and hierarchical labels have different types: input, output, bidirectional, tri-state, and passive. The style only affects the appearance of the label, not how it connects. ERC also won't check this. For example, here, this label is a hierarchical label. Let's look at its properties. Here you have input, output, bidirectional, tri-state, and passive. Here, whatever I select as the input, no matter what I choose, it won't affect how this label connects. I can select either input or output, and once I connect it at the top level, its electrical connection is established, and the ERC won't check it either. For example, if I set this as input, then at the top level, even if this pin is also set as input, it won't report, ERC won't check for this mistake. So why should we avoid using global labels in hierarchical design as much as possible? Because hierarchical design aims to clearly abstract the structure of the design into modules. This abstraction helps engineers separate the contents of the current module from the rest of the system. For example, here we make the LED and its driver chip into a single module and only expose 4 interfaces to the outside. No matter how many times this is used, the module can be directly reused. It has an independent function, making it convenient for us to reuse. Any form of global label requires knowledge of all modules in the system to ensure that no incorrect network connections are created. That is, labels with the same name will be connected in the network when using global labels. In other words, before using global labels, you must know whether there are labels with the same name in different schematic modules to avoid connection errors. As I mentioned earlier, for example, if you use a global label and you use QA as a global label, but then you also use QA as a local label here, it will cause a connection error for QA on this page. Therefore, it's generally best to avoid using global labels and instead use hierarchical labels to connect between different pages. This is especially true for large-scale designs, which may not be completed by just one person, but by a team. In such cases, everyone must be aware of all the global labels, which is very difficult, and they can easily lead to some people accidentally creating duplicate global labels when naming them. So by using hierarchical design, each part is only responsible for its own module, and the entire design won't have global labels. The hierarchical labels that a module outputs externally are what connect different modules, while within the module itself, all the labels are local, preventing any accidental connections with labels from other modules. However, power supplies are global labels. By default, this is set by the systemso. You need to pay attention to this. When designing, especially when collaborating with others, everyone needs to agree in advance. What label will we use for 5 volts and what label for 3.3 volts? And for different grounds like digital ground and analog ground, which labels will we use for each? This must be standardized and agreed upon. But in practice, you can also treat them as local labels, as hierarchical labels, and not use the global 5 volts label. Let's take this design as an example. We'll delete the 5V and ground connections. I'll proceed to place a hierarchical label here for instance. Let's consider using LED 2_5V to accurately represent its 5V power supply, and we will carefully position it right here in this specific location. Then we will proceed to add a comprehensive ground label for it as well, connected to ground. Next, we will then synchronize these particular labels to the module by carefully selecting both of the labels, ensuring a precise and accurate connection. Now, this module has these 2 nets. Here, all connected to 5V. This way, voltage transmission can also be achieved, and in fact, this method is even better. With this approach, there are absolutely no global labels in the subdiagram, and the power supply for each module is also very clear. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you everyone.